Okay, specialist paper 2, Tech Active from 2023. And we're going to be doing question 18. Which is a complex number question. Consider the complex solutions for the following equation where the arg of z is between 0 and pi. Note the arg of z is not equal to 0 or pi. And we're given considering the equation. W1 is the solution with the maximum possible real part, and W2 is the solution with the maximum possible imaginary part. And we've got to show that W1 to the 4th over W2 is an integer. So let's start. We've got z plus 1, z to the 14th, minus z 13th, plus z squared, minus z to the 11th. Nice pattern. We're adding the ones with even power, and we're taking the ones with an odd power. And that equals 1 minus z. When we expand this out, z to the 15, then we do z times that plus 1. That gives me z to the 14. When I expand the next one, I do z times negative z13. That'll be take z14. Take z13, that one. Then I do z times z12, gives me plus z13. 1 times z12 gives me plus z12. And then z times take z11, take z11. Notice now they're all going to cancel, aren't they? That pattern is going to continue. I don't need to write it all down. When we get down near the bottom end of the scale, we're going to have z, say, times z squared. I'm going to get plus z cubed, plus z squared, z times take z squared, plus 1, take z. Oh, I don't need that bracket, sorry. Minus 1, take z. These are all cancelling, and that z cubed would have cancelled with the pair before it. So I'm going to get left with z15 minus z equals 1 take z. Z take z to the 15, I apologise, I said that wrong, is equal to 1. So that all simplifies down, and we end up with, we need to start thinking about our roots of unity, don't we? Z to the 15 equals 1. Now, some people can directly write the solution from there. If you need a bit of prompting, if you're thinking, oh, working my way through because I've forgotten, 1 is cis 0 in terms of a particular solution. And then Z15 would be cis 0 plus 2 pi k in my general solution. I should know this. 2 pi k, 2 pi n, whatever you use. Some people use a k, some people use an n. We're just going to have multiples of 2 pi as my general solution. So z to the 15th equals cis 2 pi k. We then take the 15th root, and we get cis 2 pi k 1 over 15. So of course, using de Moivre's theorem, that's 2 pi k on 15. Now, in terms of marking, you get it down to, you do this expanding and you get to z to the 15th equals 1. That's 1 mark. And then from there you get the solution, which is cis 2 pi k on 15 or 2 pi n, whichever you use. This working is not necessary because you could just know that, and that's a straightforward. But that's just the work through if you needed some prompting, or if you're like, oh, I've forgotten exactly what the jump straight down, you can get there. Now, remembering with these roots of unity, oops, this is my real, this is my imaginary. Now, my arg up here does not equal 0 and does not equal pi. Because we know our first solution with k equals 0 would be the 0.1. But that's not within our domain. So our first one out would be 2 pi on 15, wouldn't it? And then we'd have 4 pi on 15, etc. So our things would be 2 pi on 15, 4 pi on 15, 6 pi on 15, 8 pi on 15, 10 pi on 15, 12 pi on 15, oops, 14 pi on 15. Oops, not evenly, they would be evenly spaced around here. Okay, we're good. Now, W1, maximum possible real part. Okay, oops, my writing, apologies for my writing. So W1, solution with the maximum possible real part, and W2 is the solution with the maximum possible imaginary part. Now, the maximum possible real part would be the one closest to 0. So W1 equals cis 2 pi on 15. You could check that with your calculator, couldn't you? And you could go, what is the cos of 2 pi on 15? And you'd work out what the real part is, what the x and the y. Your W2, maximum possible imaginary part. So that's going to be closest to pi on 2. So back on my little diagram, as they're spaced around, which one's going to be closest to pi on 2? Now, half of 15 would be 7.5, wouldn't it? So the closest one is going to be 8 pi on 2, 8 pi on 15. There. So W2 is going to be cis 8 pi on 15. Now, W1 to the 4th over W2 is going to be cis 2 pi on 15 to the 4th over cis 8 pi on 15. Using our complex number rules, that's going to be cis 8 pi on 15 over cis 8 pi on 15. That equals 1, which is an integer. Therefore, W1 to the 4th over W2 either is an integer, or if you want to write is that, which is what we needed to show. Marking scheme wise, have W1 as that, got your mark, having W2 as that, got your mark, and then showing it was the integer, got your mark. And that's that question.